Well, hello and welcome to this exercise on stationary points and implicit differentiation. Again, an iGCSE A-level high school type calculus question. And it says, show that the graph of xy plus 48 is equal to x squared plus y squared has stationary points at the points 4, 8 and minus 4, minus 8. And the second part says, determine the nature of these stationary points. Right. Now, you will have noticed that for this equation here is not in the form of y is equal to something, something, something. So we need to use implicit differentiation. And also because we got xy there, we need to use product rule. Now, if I now copy down my equation again, x squared plus y squared is equal to xy plus 48. And if we then subtract xy from both sides, we end up with x squared plus y squared minus xy is equal to 48. We can now go ahead and differentiate with respect to x. So x squared then becomes 2x and y squared becomes 2y dy dx. And the product rule applies. And we have 1 times y, which is differentiating x, 1 times y plus x times 1 times dy dx. So the bit in red is differentiating xy. And of course, when you differentiate a constant, we have 0. If we then collect like terms, we have that 2y dy dx minus x dy over dx plus 2x minus y is equal to 0. If we then factorize these two terms, we end up with 2y minus x times dy over dx, okay, plus 2x minus y is equal to 0. Okay, now when 2x minus y goes over to the right hand side, the signs will change. It becomes y minus 2x, and then we divide by 2y minus 2x, 2y minus x. So dy over dx then becomes y minus 2x divided by 2y minus x. Now, don't forget that at the stationary point, we expect dy dx to be equal to 0. So let's test it. If we now look at the point 4, 8, and then substitute x with 4 and y with 8, we end up with dy over dx is equal to 0, because 8 minus 8 is 0, so that becomes 0. So in effect, at 4, 8, we've got a tangent parallel to the x-axis, and that's a stationary point. Similarly, for the point minus 4, minus 8, we have that dy over dx is equal to minus 8 plus 8 divided by minus 16 plus 8, that's equal to 0. Again, suggesting a tangent parallel to the x-axis. So we've now established that dy over dx is 0 at this point. Now, for the second part, in which we are supposed to determine the nature of these stationary points, if we then copy down our dy over dx again, and that's equal to y minus 2x divided by 2y minus x. Okay, if we then cross multiply, we have that dy over dx is equal, dy over dx times 2y minus x is equal to y minus 2x. Okay, now we need to differentiate the first. On the left hand side, we've got two terms here. We've got the dy over dx term and also the 2y minus x term. So again, the product rule applies. So if we differentiate dy over dx first, we have d2y over dx squared times 2y minus x, and then we differentiate 2y minus x, and we have dy over dx times 2 dy dx minus 1. On the right hand side, we have dy over dx when we differentiate y, minus 2 when we differentiate 2x. Now, we've now established from here that dy over dx is 0. So in there, this dy over dx is 0. This dy over dx is 0, which means this term is 0. So we end up with d2y over dx squared times 2y minus x is equal to minus 2. Okay. So now, if we divide by 2y minus x both sides, end up with d2y dx squared is equal to minus 2 divided by 2y minus x. If we now substitute 4 for x and 8 for y, we end up with d2y over dx squared becomes minus 2 divided by 16 minus 2, and that will give us a negative value. So it's less than 0, which suggests a maximum point. So the stationary point 48 is a maximum point. Okay. Similarly, if we then substitute for x equal to minus 4 and y is equal to minus 8 into our result for d2y dx squared, we end up with d2y over dx squared being minus 2 divided by minus 16 plus 2, and that will give us a positive value that's greater than 0. So that now becomes our minimum point there. So minus 4 minus 8 is a minimum point, and 4, 8 is a maximum point. And I hope all that made some sense, and please subscribe. Thank you for watching, and bye-bye now.